So this is going to be a video on cyclic quadrilateral and the fact that opposite angles in a cyclic quadrilateral will add up to 180. I'll do two proofs of this. One's going to be more easier than the other. I'll do the easy one first, so if you understand that, you can move on. But here we go. So the proof is the opposite angles of a cyclic quadrilateral add up to 180. So first, let's just draw up a cyclic quadrilateral. So I'm going to exaggerate this a bit, just to really drive in the point of what's going on. So first I'm going to draw up a quadrilateral inside this circle. So, yep. And I'm going to label these points A, B, C, and D. And I'm going to label the origin right there. I'm going to label that as O. So what it's saying is that, sorry, I'm just going to change color. What it's saying is that when you add, for example, angles B and D together, you'll get 180 adding up. So the first way to do this is to first, let's join up A to O. Okay, and then after that from O to C. So, if we just break this up into two bits, you can see that following from first theorem that we did, you can see that there's an angle right here. And we're going to call that angle something later on. So I'm going to call this angle right here, let's just say for angle's sake, T. That angle right there is T. And if we call back from theorem 1, we can say that this angle right here is 2T from the double angle theorem. From there, we can say the exact same thing with this right here. If we call that angle Y, we can say that the angle right here is also 2Y, just using the double angle theorem. So if we just change color for a second, so I'll use purple. So if we look at this point right here, you can see that 2t plus 2y, they are about a point, or in other words, about a reflex point, and they should add up to 360 degrees. So if they add up to 360 degrees, we can factorize this. We can say 2t plus y is equal to 360 degrees, or in other words, t plus y equals 180 QED. So that's just a very simple proof using that. And that holds for all opposite angles in a cyclic quadrilateral. So this is a more winded proof, but it still drives in the same points. So again, if we want to draw up another cyclic quadrilateral, I'll draw up another one. And here, just draw up the points. You've got C, and you've got there, there. Okay, I'm going to label this as A, B, C, D. So we can say that this angle right here, we'll call this angle X. Therefore, this angle right here will be 2x from the double angle theorem. Okay, and I'm going to label this point right here as O. That should have been O. So we're going to say, let the angle ABC, let that equal x. Therefore, AOC is equal to 2x. Therefore, what we can say is that the reflex part of it, so I'm just going to change color just for a quick bit. This angle right here, that will be, so the angle AOC, but the reflex bit will be 360 take away 2x. Therefore, we can say, since the double angle theorem is like this, we can say that the angle ADC is just everything here divided by 2. So in other words, 180 minus x. Okay, just dividing everything here by 2. So after that, we can say, we can conclude with the fact that we can rearrange to get angle ADC plus x should add up to 180 degrees. Well, guess what? What did we label x as? We labeled x as this thing right here. So we can say that ADC plus angle ABC should add up to 180 QED. So, once again, two different ways to prove that this angle plus this angle is equal up to 180. Or if you just go back to the previous one, right there, it's as simple enough as doing, doing something that's easy.